Third, I think we also see some indicators of differential erosion. We're far from testing it and far from testing whether differential erosion is related to elevation, but we see that in one portion of the landscape he analyzed, the mounds are very regular, and that is the pattern that humans made. They aligned these mounds in rows and columns. We see that everywhere where people build wetland raised fields, in Africa, and as they still do today, and in South America, where the practice died about 500 years ago. And the signal has been degraded by actions of engineers or by erosion to produce areas where the orientation is not as great. And that is important for a reason that I'll tell you right at the end of my conclusion. Another thing, LiDAR can see these small mounds even under trees, and that's important. When you look at these areas, it almost looks like an orchard. So how do you interpret this looking at it? You might think, oh, humans did that. Yes, humans did it, but humans did not plant the trees. Those trees are there because of the human-created topographic differences, and they came later. As one of the slides of Cedric showed you, there was a perfect correlation between where a mound is and where a tree is. Again, those trees were not planted. They ended up there because the ecological conditions were different, offering better conditions for woody tree roots there than just next door. So it's important to have a lot of information when you try to interpret these landscapes. And that is interesting for another reason. You may know that there is a big controversy in Amazonia, both in forest and savannas. How much, there are some people who are saying, oh, Amazonia is just a cultural parkland shaped by human activities. Other people say, no, it's all natural. I think there's a middle way here, but we have to look at how humans and nature interact to create complex landscapes, more complex than either the archaeologist or most ecologists think. And one of the controversies in this area, those of you who are from the western US may know Mima mounds. Well, those have a complicated history, but they look like this, but they're made by pocket gophers, a rodent. Very regular landscapes. I myself have worked in Colombia on landscapes that look like this, but they're made by a giant earthworm. Termite savannas also are common here. And there's most of the archaeologists, when they look at these landscapes and they see regular spacing, they say, ah, humans, those are raised fields. In fact, what we have found is that there is a nice signal for what is raised fields and what is natural. And it's not the regular spacing. You have self-organization processes in ecology that can produce regularly spaced landscapes, and we've seen them. What is different so far that we've found is the regular orientation. In nature, the mounds created by natural processes are regularly spaced, but not regularly oriented in rows and columns. It's only the human-produced structures that are oriented in rows and columns. But as you've seen, erosion of the human-based structures can degrade this row and column signal. So it's very important to sort that out and use that information as part of this big controversy, what is human, what is natural. And I see a lot of potential in sort of data that Cedric is producing to advance on this and produce some very interesting stuff. It's not going to make much money, but it's certainly interesting and a lot of fun. So I want to thank, first of all, YellowScan and the organizers for inviting me here. This is an audience I usually don't have associations with, and it's really broadened my horizons looking at some of these talks. So thank you very much, and thanks for the collaboration.
But I have heard that it has also an ecological meaning for today's agriculture. Can you explain us?
Yeah. As I showed you, the first cover slide, the cover back illustration in the first slide was from Republic of the Congo. This is part of a project looking at these earth mound landscapes in seasonally flooded savannas all over the world, mostly in Africa and in South America. In South America, raised field agriculture died at the latest with the European conquest. Whereas in Africa, there are not only archaeological raised field sites, which you saw in the first slide, but people in many parts of Africa are continuing raised field agriculture. And this is an interesting thing because what does intensive agriculture usually do with floodplains? A couple of things: industrial rice production or draining. Okay? Both ways, biodiversity and ecosystem functions often get zapped. This is a way it may not be as productive in the short term as industrial rice culture, or what you can get in a few years of organic matter-rich drained soil before the organic matter gets oxidized. But it could be a way to have at least a modest scale of agricultural production while working with wetlands, sustaining their biodiversity and the ecosystem services they provide. So one of the prongs of this is it's not just trying to understand the past in South America, it's trying to understand the present and the future of wetlands in Africa and looking at this as an alternative to other ways of farming wetlands that destroy wetlands. This is one that could potentially work with them. So yes, there are some applications, and I have a postdoc who's starting, will be going in August and September to Republic of the Congo to watch present-day raised field farmers and how they work. And we also think that can help us understand how the pre-Columbian Indians worked. But the main point in Africa is to see how these people managed their soils and how they were able to do, as we have documented for sites in South America, keep farming these wetlands for periods up to 300 or 400 years.
Doyle, you explained the difference between man-made structure and naturally made structure. But this was maybe like at the beginning of the construction of this structure. But now, so even the man-made structure are naturally maintained structure, right? And so I would like to understand does this can help you? What do you understand by this? Like, is it the origin? Is it man-made or naturally made? What explains to you?
Okay, well, as you saw in the landscapes I presented from French Guiana in my slides, and as you saw in the area that Cedric showed the illustrations in Bolivia, the general signal in these areas is a square grid. And what we've found so far is that is a signal of human activity. So that human origin is still preserved here. Okay? We find other kinds of interaction between human and natural processes that go in the other direction. For example, one of the other engineers that makes landscapes without human help are termites. You have huge areas of termite savannas and wetlands, regularly spaced termite mounds. Well, what we found in Africa, and one area in Bolivia seems to show that pre-Columbian Indians did the same thing. We find this landscape, which is inhabited by termites, and the spacing and lack of regular orientation indicates it was made by termites. And in Africa, we find people saying, oh, that kind of looks like a raised field. Somebody has already done the work for me. And so they will just put a raised field on top of a termite mound. So you have all kinds of situations where you can have raised fields and they're not regularly oriented. But if you understand the interactions and look at this over time, you can figure that out. We need that kind of complexity that puts archaeology and ecology together. Neither ecologists nor archaeologists are going to solve this alone. But there are ways when you put all of them together that you can interpret the origin and the history of these mounds.